Hello, good evening. So today we have a question before us. This question type is fairly common. You must have seen questions like this, obviously with different values and in different scenarios, right? But essentially the same abstract, in an abstract way, the same kind of question, right? In a lot of competitive exams and a lot of aptitude tests and a lot of petty scenarios. So this is a very, very common question type, right? And there's a very standard way to solve it, and that is the way that almost everyone blindly follows, indiscriminately follows, right? So this particular question with this particular set of values and the situation explained here, this is an actual CAT question, question from CAT 2019 slot 1 paper, right? So this is a previous year actual CAT question. Now you can see the question on your screen, and you can see a little graph, which is obviously not a part of the question paper. This little Venn diagram, right, is something that I've made myself and added it here. Rest of it was given in the question, right? A club has 256 members, and these are the four options that were furnished. Now, if you look at the various ways in which people have tackled this question has been posed in various places and even a few instances in popular fora and websites outside India. So this particular question, almost everywhere that I have seen it, right? I've seen it being tackled in the exact same formulaic, conventional, orthodox fashion, right? So I'll explain both the formula based approach and the shortcut based approach in this video, right? So let's first go with the pretty standard formula based approach, right? So I'm going to use the capital letter U to show union in set theoretic language, and the small letter N, small alphabet, lowercase alphabet N, to denote intersection, right? So the formula looks pretty intimidating if you haven't already encountered it, right? If you haven't encountered it before, you'll find the formula intimidating looking, and if you have if you are aware of this formula, most likely you'll find it okay. Here we go again, right? Very pretty monotonous. At any rate, let's just write it down. Let's solve it the common method that you'll find everywhere first, and then I'll tell you the shortcut method. So let's start with a pretty basic approach first. So NA union B union C is equal to N of A plus N. Let me just write down the formula first. N of B plus N of C. And what I can do, since I'm going to represent union, since I'm going to represent intersection with a small n, let me just represent this with a let's say a capital N, right? So n denotes the number of something. It denotes the count of a particular value, right? So how many members are there in a set? So let me represent the count of a set with a capital N, right? The number of members in a set with a capital N. So Na plus Nb plus Nc, right? And then we go minus, and let me just write it in this format, which makes it conceptually easier to grasp. So n of, which is number of such things, and capital N here represents the cardinality of the set, or the count of the members of the set. How many elements are there in that group? Very simple. How many members are there in that group, or how many elements are there in the set, right? In the set theoretic language. So Na plus Nb plus Nc, and then we subtract Na intersection B, right? Plus, and every plus sign here will eventually open up to a minus sign, as you can see. So N B intersection C, and then we have N C intersection A. So in case you find these terms confusing, I'll just explain them to you. So bear with me for the time being, for a moment, right? C intersection A, right? And that's what we have at our hands, right? Pardon the autocorrect here, right? And then we have a term to add here, right? So it's going to be N of the intersection of all three. So we have N intersection B intersection C, right? Now I'll explain graphically for a bit for those who are unaware as to what these terms exactly mean, right? So union simply means or, the or of the or word in English, right? Logical or. So union means either A or B. So when I say A union B, it means an element belongs to either A or B. If an element belongs to either A, or if it belongs to B, right? And or if it belongs to both of them, that's fine, right? It belongs to their union. But intersection, which is represented by this inverted U sign, or let's say this N sign here, right? Intersection means and, A-N-D, and. So it means that C intersection A, for example, C intersection A means an element which belongs to set C and set A both. If it belongs to set C but not to set A, it does not belong to set C intersection A. Right. If it belongs to A but not to C, it does not belong to C intersection A. It only belongs to C intersection A if it belongs to both C and A. So it must belong to C as well as belong to A. Right. So this is the basic definition, and I can even explain it graphically. Right. So let me instead, this is a general formula, right? I hope all of you are aware. Right. Let's just represent A, B, C in terms of tennis, cricket, and football. So let's pick a particular order. It doesn't matter what order you pick, right? But once you pick a particular order, if during the solving, if during the same solution you change that order, that's going to make your solution inconsistent and going to lead to wrong answer, right? So pick one order. As when you're picking, you're free to choose anything, but don't change it midway, right? So let me go in the order in which this is given. So let me go with football as A, let me go with tennis as B, and let me go with cricket as C. Okay, A, B, C. So let's go with football here, right? And let's go with tennis here, F, T, C. So we're going from F, right, to T to C, clockwise direction. Okay, in that order. So F, T, C, and I make the substitutions. F, football first, then tennis, then cricket. F, T, C, and we go here, football, tennis, and all the way here as tennis, cricket, and then cricket, football, intersection and union are commutative. So I can write F intersection C or C intersection if they mean the same thing, right? And A intersection B intersection C is going to be F T C. Okay, and I'm going to explain what these terms mean. So N F union T union C means people who play either football or play cricket or play tennis, right? So suppose imagine yourself to be the president of the sports club or the manager of the sports club. So you are looking for tickets, right? You're looking for or let's say whenever someone joins a sports club, they are allotted an identity card, or they fill up a form. They fill up a form for admission into a particular sport, right? So let's say you get 100 forms, right? But there are only 90 people total in your uh, sports club. So there are 90 ID cards, but 100 application forms. How can it be possible? And certainly a person who has a certain ID card, right? If your club allots one identity card to a particular person only, right, for the entire club, no matter what sport event they participate in. So it must be that there are some people who are playing multiple sports, right? So that's why you get three application. One person can apply for three games: cricket, tennis, or football. So that's the thing, right? So when I count the number of application forms, I'm overestimating the number of people who have joined my club, right? So NF union T union C, right, is actually representing this area of this shape, this clover like three petal clover like shape, right? So this shape is being represented by F union T union C, right? And since some portion of it is overlapping, the area of this shape will obviously be less than the sum of the areas of these three shapes, these three circles combined, right? So this plus this plus this, the area will be less, right? So I'll have to subtract something from the RHS in order to get the LHS. So I subtract this overlap, right? And I subtract this overlap, and I subtract this overlap. But when I subtract these three overlaps, I actually need this central area back, which is actually now getting over compensated. So I recompensate it back in the opposite direction, right? So plus minus plus, I keep altering the signs, right? So this is the geometric significance of the formula, right? So this is what we are essentially doing here, right? This is the intuition behind this formula, right? Now let's just plug in the values and see what we get. Now every almost every website that I have seen, right, you'll find the same thing being done. So let's just see what should we do. Yeah, so let's find the value of x, and x will be, let's just write it here. Yeah, and quickly find x, right? So 58 plus 25 plus 63, it's going to be 88, and 96 plus 50, 146, right? And 146, and x is sent there, so 256 minus x, right? If we send x there, or we could leave x here and calculate, either way is fine. So 256 minus x, will be 144 plus 123 plus 132. So it's going to be 155 plus 144, 399. Yes, 399. So let's write a 399 here, right? And minus, what was that? 146. Yes, 146, right? And very quickly, let's go with, yeah. So we have x, uh, x equals, yeah. So 399 minus 146 minus 256. So 256 this side and 146 is subtracted. So we're going to get x equals 3, right? So x equals 3. How many steps did this take? How many steps? Let's just count the number of steps. And mind you, we have not found the solution. What was the question asking? Then the number of players, right? Read the question. What does the question seek of you? This is something that you should have ideally done at the very beginning, right? So number of players who can play only tennis. So X is not the answer. This is not the region, right? That we are looking for. But yeah, X is an intermediary. So how many steps did we take to arrive here? Right? You can simply see it from the formula. If I need to find this, right? So what can I do is, no matter how you do it, you have to perform 1 addition, 2 addition, right? 3, 4, 5. You can change your addition to subtraction or subtraction to addition, but you're going to have to perform the same number of addition or subtraction binary operations, right? So 1 operation, 2 operation, 3, 4, 5, and 6, right? So if I leave it this side, right, if I have to find f intersection T intersection C. Or let me show it here. I have to find the value of X, right? So I have to perform 1 operation, 2 operation, then I get a number and I subtract it. 3 operations, and here I've already done 4 and 5. And then I have to send this entire thing to the RHS to subtract it, 256 minus X, right? So I'm essentially performing 1, 2, 3, 4, 5, and 6 operations here, right? So in 6 steps, what I'm finding is X, which is not even the answer, right? So that's how long it takes. Now I have X is equal to 3. Now they're asking me the number of players who play only tennis. The number of players who play only tennis is basically the number of players who play tennis minus the number of players who play any other game as well as tennis. So this can be simply stated as the number of players who play only tennis is the number of players who play tennis minus the number of players who play tennis and cricket minus the number of players who play football and cricket plus the number of players who play all 3 games, right? So number of players who play tennis minus the number of players who play both cricket and tennis minus the number of players who play both football and tennis, right? Plus the number of players who play all 3 games. So I have to find this moon-like region, or let's say Jedi symbol-like region, right? So this half moon or sort of, this shaped region that represents number of players who play only tennis. So such players who don't play any other game, exclusively tennis. So this is going to be total number of players who play tennis, this yellow region being overcast, being superimposed by cricket and football partially, right? Minus the number of players who play both cricket and tennis, represented by this orange region, right, with some half of it blackened up, and minus the number of players who play both football and tennis, which is represented by this green region, again overlapped by the black core, right? And then plus this black core. So minus of minus, you get plus nested, right? So let us perform that calculation and then we'll have our answer, right? So let's just do that. So what we need to find, number of players who play only tennis, right? So that can be represented as n of, right, let's say T. So n of T, right, number of players who play only tennis. So number of players who play only tennis can be represented as or total number of players who play tennis, including those who play other sports, right, minus number of players who play excuse me, minus number of players who play both tennis and cricket, minus number of players who play tennis and football, and plus number of players who play tennis and football and cricket, right? So this is the number. So let's calculate number of players who play tennis provided in the question, 1, 2, 3, minus number of players who play tennis and football, right? Number of players who play tennis and football, that's 58, and minus number of players who play cricket and tennis, that's 25. Sorry, yeah, football and tennis, or tennis and cricket, right? And then number of players who play tennis and football and cricket, right? And this number we have obtained after a lot of labor, it's 3, right? So number of players who play only tennis is number of players, total number of players who play tennis 123, minus number of players who play tennis and football, which is from the question 58, right? And minus number of players who play tennis and cricket, which is uh, given as 25, right? And plus number of players who play all 3 games. So 58 represents number of players who play both football and tennis but not cricket, and 25 represents number of players who play tennis and cricket but not football, right? And 3 represents players who play tennis, cricket and football. Okay, and after performing this enormous calculation, right, what we get is 123 minus 58, or you can just, to get a better feel of this, what you can do is you can write it in this bracket form. It's the same thing, no magic here, right? And sort of, yeah, this is a better representation, right? Makes another way of solving it. You can just see it in the diagram, right? When the minus sign will open, things will fall in place. So 58 plus 25, 68, 73, minus 3, 70, right? And 123 minus 58 plus 25 minus 3. So we're going to get 78, 83 minus 80, right? And you're going to get 43. So this is the answer. This answer was obtained after so much labor, right? And this is the method that you'll find across websites, across solvers. Like, this is the method which is recommended. Like, just see how many steps does it take, right? So you have another 1, right, 2 and 3 steps here, right? So initially you took 1 step here, 2 step here, 3, 4, 5, right, and 6, and here 3. So total of 9 steps to get the answer, right? 6 steps just to find the score. Now let me tell you, you don't even need all the data that is given in the question in order to solve this question, right? You don't need all the data. Yeah, in fact, the problem with the conventional approach is that it takes a lot of steps, like 6 steps to find just an intermediary, right? This black region. Can I proceed without finding this black region at the core? Can I solve the question without it, right? So let's try to bypass finding this region. What if I don't find this region, right? Can I solve it, right? So essentially what I have to find is this. Imagine this on the Venn diagram. I have to find this semilunar yellow region, right? This moon-like yellow region, right? So instead of like doing all this, first I with a lot of difficulty, I take all 3 circles, add them, find this, then do that. What if I directly find this region? So if you can see, I know what this region is, right? This entire region, right? What is its area, right? If I draw it more regularly, this region that I'm supposed to find, this area is nothing but 256, right? I've already been given that, right? And if I subtract this 8 region from here, this dumbbell shaped region, I can get this semilunar region, right? Just show you on the Venn diagram, right? If I take the entire thing here, right? So if I take this entire thing, and this is the total number of members, right? And the total number of members will always be less than the sum of all 3 disks, since some regions are overlapping, some regions are hidden one over the other, right, where you can see the secondary colors. So if instead of so doing all that, if I take simply this region and I subtract this 8, or let's say lemniscate shaped region, this sort of dumbbell or infinity symbol shaped region, if I subtract this 8, right, this tilted 8 shaped region from this clover 3 petal shaped region, won't I get this desired region directly without having to find this black region, right, this brown region at the core, right? Can I just subtract and find this region? Let's just do that, okay? And instead of using the formula for 3 circles, 3 Venn diagrams, I can simply use the formula for 2 Venn diagrams, right? That formula is much easier, right? Much more intuitive, right? So it's based on the same intuition as the 3 formula, but this is a formula that almost everyone knows, right? So n of A union B is n of A, right, plus n of B minus n of A intersection B, right? And instead of A and B, we plug F and C, right? Football and cricket. Football, cricket, football, cricket, and football, cricket. So number of players who play either football or cricket is equal to total number of players who play football plus total number of players who play cricket minus total number of players who play both football and cricket. So simple. Just ignore T for the timing. Just look at these two circles. So I essentially what I'm doing here is I'm trying to find, just look at C and F. I with my LHS I need to find this region. So initially I added the two circles, but that area would have been more than required, right? So this would have been something like this, right? RHS greater than LHS, right? But then some region is overlapping here, and this is exactly the region which is being double counted and needs to be subtracted. Nothing needs to be compensated here since there's only one overlap here, right? So this is the region that I subtract from this, right? This eyelid or boat or penguin or biconvex lens petal leaf shaped region, right? So this is what I'm going to do. So see, I'm not even using, look at this is the shortcut method. Look at the number of steps at even the number of data that I'm using. So I'm using one data, F union C, right? What is F union C? F union C is number of players who play football as well as cricket. Now I don't know this, right? So this is equal to NF plus NC minus N of F intersection C. So my N of F union C is equal to, what is NF? Number of players who play football, regardless of what other games they play. So 144 can play football, and how many can play cricket? 132 play cricket. And how many play both football and cricket without regard whether they play a third game or not? Everyone is counted. So 63, right? And what is the number that it gives me? 144 plus 132 minus 63. So what is the number that I'm going to get? 145. Make it fast. 270. If you add them, 276 and minus 63. So what I'm going to get is 213. Let's pause for a moment and see if this calculation is correct. 144 and 130, 140 and 130, 270, 276, 276 minus 63, 76 minus 63 is 13, right? So we get 213. Now, in a single step, I needed to find n only t, right? Just t, right? So n only t is nothing but n of f union t union c minus n f union c, right? So what I'm doing, I'm taking the entire three petal region and subtracting the dumbbell shaped region from it, right? So 256 minus 213, right? And we directly have the answer 43. Look at how many pieces of data I used. I only used this 144 here, this 132 here, and this 63 here, right? And this 256. Only 4 pieces of data. I did not even need the number of players, total number of players who play tennis. I solved it without knowing this. Had this not been given, I would still have solved the question. I did not use the number of players who play both football and tennis, nor did I use the number of players who play both cricket and tennis. I only use the number of players who play both football and cricket. That's the only intersection I use. So what I'm doing, I am, like if this is the region, I have to find this, right? So why don't I just take the entire thing and I subtract this dumbbell shaped region? So that's what I'm doing. In order to find this, I know the total is 256. And this 8 shaped region, I found it out to be 213, right? In only 2 steps, right? 2 operations. So see the number of operations that I perform, number of steps, 1 operation, 2 operation, and then 1 subtraction here. So only 3 operations compared to 9 of the conventional method. So this is again not a shortcut method. This is just witty observation, not very witty either. It's very obvious, right? But that has to click in your mind. It has to strike in your mind. And if you're conceptual, it sure will, right? So see how short and easy a question becomes once you start observing, right? So that's it for today. Thank you. Have a nice day.